Let's take a look at this question here. We have a function f of x equal to x squared plus 6x plus 5. And the first thing we need to do is to use the definition of the derivative to find the derivative of that function. Now, later in the course, you're going to learn how to find the derivative very fast. When I look at this function right away, I know the derivative is 2x plus 6. And those are techniques you're going to learn later. But for right now, the only tool you may have to find the derivative is the definition, and that's a limit definition. And it'll be easy to find the derivative using that definition. That won't be very hard. And then once we have that derivative, namely 2x plus 6, we need to answer some questions here, A, B, and C. How do you find the slope of the tangent line at x equals -1? Well, our derivative is really a formula for the slope of a tangent line. So to answer A, all we're going to have to do is to substitute x equals -1 into the derivative. And then after that, we'll find the y value that goes with x equals -1. That's question B. And then part C is just to find the equation of the tangent line at x equals -1. So why don't we start? Let's see here. Let's first do the derivative, okay? Now, the definition of the derivative is this. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. A lot of times people use h. Some people like to write delta x there. I hate delta x. I hate writing that. I think that's terrible notation, so I'm not going to bother with that. If your teacher wants you to use delta x here instead of h, it's no problem. Just wherever you see, it looks like there's 3 occurrences of h here. Each occurrence of h, just replace it by delta x. So if your teacher wants you to use delta x, it's no big deal. Just wherever I write h, you should just write delta x, right? So let's see here. What happens? What is f of x again? I think it's x squared. Well, why don't I just look? It's x squared plus 6x plus 5, right? So I'm just going to do something over here for a second, okay? F of x is x squared plus 6x plus 5. What do you think f of x plus h would be? The way I'm going to answer that is like this. F of anything is equal to what? Well, it's that thing squared plus 6 times that thing and then plus 5, okay? So if you understand what I'm doing here, really all I did is I replaced x by an empty box. And you can really put anything you want inside of that empty box. In this case, why don't we put x plus h? So f of x plus h, which is this expression right here, is the same thing as x plus h squared. Let's put brackets there though. Plus 6 times x plus h plus 5, okay? So I hope you agree with me that the very first step we should do here is f of x plus h, we should write x plus h squared plus 6 times x plus h plus 5. Now that's just for f of x plus h. We still have to minus f of x. I think this, I can erase this now because I made my point. Give me 1 second. I might as well erase this as well. So, good. F of x plus h is this expression right here. Now we have to minus f of x, right? What is f of x again? X squared plus 6x plus 5. Is this okay? This is actually not okay because I'm missing a very important set of brackets right here, all right? These brackets are absolutely critical to getting the right answer. If you forget them, it won't work out. You could, if you really felt like it, even put a set of brackets here, but these set of brackets are optional. these set of brackets here on the right-hand side are necessary. And the denominator is still h, right? Okay, so now our goal is to simplify all this. X plus h squared, what is that equal to? It's x squared plus 2xh plus h squared, right? Just for a quick review. If you want to do x plus h squared, I see this a lot of times, right? That's very bad. We don't want to do that. It's not equal to that. Maybe one way to do it is just to write x plus h times x plus h, and then you got to FOIL this out, right? There's going to be 4 terms. X times x is x squared. X times h is xh. H times x is hx or xh, same thing. And h times h is h squared, right? And we have 2 copies of xh, so this is 2xh. Now, and that's exactly what I had written here, right? This is actually something you should know already from this basic algebra. All right, now the reason I was emphasizing the importance of these brackets before is, you know, this minus sign, it kind of affects every single term inside those brackets. So when I get rid of those brackets, it's going to be minus x squared minus 6x minus 5, right? If I would have forgotten those brackets, I would have written here minus x squared plus 6x plus 5, and that would not have been good. All over h. I made a little mistake here, didn't I? This, I forgot. I did x plus h squared all fine, but I forgot all this 6x plus h stuff plus 5. I'm sorry about that. Let me fix that. Why don't I just move this over and give myself some more space. And let's correct that there. X plus h squared is what I written here. But then I have to also do this, right? So plus 6x plus 6h and then a plus 5. All right, now we're back on track. If you've done everything correctly, the way it works kind of is everything that does not have an h in it should cancel. Let's see if that happens. X squared minus x squared. Positive 6x minus 6x. Positive 5 minus 5. So just like we thought there, everything that does not have an h in it goes away. So 2xh plus h squared plus 6h. And that's all, right? So this is looking simpler. Now, why don't we factor out an h from the top? Since h is in every term, it's common, so we can pull it to the front. And the reason we do that is, look, we can cancel those h's now. And now we're getting close, because once these go, we have this. And you know, for every single step previous to this last one, I was not able to let h be 0 in the expression because I would have a denominator of 0. But in this last expression, the denominator has now magically disappeared, and now I can actually put in h to be 0 and get the answer. Notice I dropped a limit sign. I on all these other steps, I included the limit sign. But the last step here, I finally evaluated that limit so I can get rid of the limit sign. And there it is, 2x plus 6, right? And that's what I predicted at the beginning. The reason I knew it was 2x plus 6 is because there's lots of rules for derivatives that allow you to get the derivative really quickly. But at the beginning, when you first learn derivatives, you kind of need to go through those steps just to get some experience with it. But later on, when you do more complicated derivatives, you'll never have to go through all these limit steps again. You'll just use the rules, okay? Anyways, let's find the slope of the tangent, okay? The slope of the tangent line at x equals 1, how do we find that? Well, all we do, remember the derivative is a formula for the slope of the tangent line. And by the way, m is usually denotes slope. Since the derivative is a formula for the slope of the tangent line, if I want to know the slope of the tangent line at some number, all I do is I put that x value into the derivative. So I get 2 times -1 plus 6. All I did is I replaced x by -1. So I get -2 plus 4, or sorry, thinking ahead there. -2 plus 6, which is 4. So the slope of the tangent line is 4. Now our eventual goal here is to get the equation of the tangent line. But to get the equation of the tangent line, we need to know the y value that goes with the x value. And to do that, I put the x value here into the original function. I don't put it in the derivative, right? I already put my -1 in the derivative, and that gave me my slope. If I put the number x in my original function, the number I get out is my y value, okay? So remember what f of x was? It was x squared plus 6 times x, or in this case 6 times -1 plus 5, right? -1 squared is 1 minus 6 plus 5, and that's actually 0. Okay, so that means the point we're dealing with, excuse me 1 second, my computer catches up. The let's cancel that. So the point we're dealing with is -1 comma 0. And now finally we're ready to do the tangent line. Oh boy. I don't know what's going on there. Alright, I fixed the problem. The point we're working at is -1 comma 0. To finish it up, what is the tangent line? Well, we have all the information we need. Let's write the formula for the tangent line here. This is like the point slope formula. We have a point, right? This is our point, x1, y1. That's where we're going. Actually, I guess it's x0, y0. And the m is right here. M is 4. So let's plug those in. Y minus 0 equals 4 times x minus -1. Y minus 0 is just y. X minus -1 is really x plus 1. And just to get this into the nice form, which is kind of the y equals mx plus b form, or slope y-intercept form, we'll just write it like this. So this is the tangent line, all right? I don't know, maybe, why don't I just, this is basically the end of the question, but just to show you what this means. What does the graph of this look like? This is actually can be really easily factored, right? We can write it like this. So that means the zeros are at -5 and -1, right? Why don't I try to draw a quick little graph of that? Here's -1, say. Here's -5. And the graph is a parabola that it opens up, right? Something like this, maybe. And remember, the point that we were working with was -1 comma 0, right? And by the way, this is 5, right? So that goes right there. Let me change my color here. Now the tangent line is this line right here, right? The point of tangency is right here. It's -1 comma 0. Notice the y-intercept of our tangent line is 4, a little bit below 5. So this is the picture that's going on in the background. And it's nice to look at it to get an idea of what it really means. All right, so I hope you understood that example.